Thank you. Right, so this is a dangerous speech because a couple of years ago I was asked to talk at a conference. They've now made a series of historical special interest groups, the European Data Association, and Denmark was hosting one. And I mean, one thing was, they said we can't have one of these about the early days without talking about APL. So I was invited there. Now I had to travel a bit around and ask people, because I was not there for the first decades. I only entered APL in '83. But this talk can take anything from half an hour to 2.5 hours. So I shall try and get through all the slides and all the errors and deliver you to the next speaker in time. Right. So first a bit about the early years, and that'll have to be the Nordic countries. That's where I have my experience. I can't talk on behalf of the Americans or Japanese or other far places. Then I'll try and illustrate to you how APL has been used through the times and how APL has evolved through that time, and attempt a summary about the current state. Right, so I have to talk a little bit about myself, because the other day somebody asked me if I'd actually written APL. And I thought, man, yes. So I graduated from the Copenhagen University as a biologist back in '81. And after having taken the pedagogical education that allowed me to teach at high school, I realized that I would have to repeat 3 years of teaching in a iterative fashion for 30 years, and I decided that that was probably not what I wanted to do. So I got retrained to electronic data processing, because back then there were really no software engineers, and there was a high demand for people who understood computers. So they took academics and retrained them to EDP, and I was extremely lucky. There was one job offered, and that was with IPSA, and I got it. But we were taken through Fortran, COBOL, system architecture, CS4. That was a theoretical version of the relational model, finance, and finally APL. And obviously 2 + 6, 8. That's new. And when I saw that one, I thought, why did they bother with all this other stuff? Because there's no loops. And the one thing that's a marvel, it just tells you the result. You know, in Fortran you had to estimate how wide the result would be, and if you didn't guess right, you got just stars. So even if the program had calculated exactly what you wanted, it was not going to tell you unless you knew what it was. The APL, you just... So, I never looked back. Obviously, everybody in this room know Ken Iversen discovered APL when he was at Harvard. And it's an interesting story about Ken, and you should go and read his biography on the Wikipedia. I'm not going to repeat it here because I don't have time. But the really interesting fact that I found was that before he got to university, he actually didn't know it existed. So he grew up in a farm, the countryside. The only career available for somebody smart there was as a teacher, and he didn't want to do that. So he just idled around on the farm until he got to the military, who got him into education and finally into university. So I mean, there's still places in the world where the straight path to education is not a given. and we should maybe think a bit about that. So in '62 he published the book, A Programming Language, and the first implementation was for the 7090. It was a batch program and not the interactive APL we were used to. The interactive version and the one that spread across the world was done in 1966 on the 27th of November, and it's the birthday we are celebrating here. Now, I took this picture, that's an IBM 360, and I think the guy sort of shows you about the age, the way people were back then. In the Nordic countries, there's a guy in Denmark, Per Gialo. He had been instrumental in getting a big IBM computer at the Danish Technical University. They had created a center, the Northern European Computing Center, and that had one of these 7090s, and that was supposed to service the whole of Europe with computing powers for all the universities. But there was a guy there, Hans-Jørgen Helms, and he started a summer school where he introduced or wanted to introduce all the computer languages to interested parties, basically. So you could come there as an engineer or somebody working in a bank, and there was quite a few people there, and they were shown Snowball, Lisp, Algol, and then Ken Iversen with APL. And the interesting thing is, it was the interactive version, but NOS had a 7090, so what did they have to do? Well, Trondheim University had a 360. So Larry Breed and a young IBM guy called Henrik Nystad traveled to Trondheim with a big tape, installed it there, and then they coupled with one of these teletypers to the Trondheim University, and then they had a TV camera showing the terminal so that people could actually see what was happening on the terminal. So back then there was a company called ÖK Data. It was a big shipping company who had made their own time-sharing service, and they had just opened one with BASIC, and IBM didn't really know what to do with that, but the sales guys heard of this APL thing. So soon after, IBM offered time-sharing service on a System 360 Model 40, up to about 30 simultaneous users on a probably not 300 baud even, less than that. 134.5. Yes, probably. Also, the local government's IT service center started time-sharing services, and that was all sorts of municipal calculations and accounting and stuff. But there was a guy there, Jus Nielsen, who thought that APL should also be offered to the schools so that kids could experiment with math, just like they could do physics experiments and stuff. It never really happened because I think it was too difficult. They were traveling around with a teletype terminal and an acoustic coupler, and it was quite expensive both in terms of phone lines and the time-sharing fees. So it never came off at the schools. In Sweden, there's a guy called Sten Kalin at IBM. He heard of APL and ordered it for his 1130. And he was doing logistics programming in Fortran, and so he really liked the fact that he could interactively use APL to develop things, prototypes, quickly. So he got really interested in APL and taught a lot of courses and got his friend at Volvo very interested. And even to this day, Volvo is using APL big time for planning their production and even dimensioning boat propellers and stuff like that. Oh, he also worked with an artist, and this is a famous piece of textile that's actually exhibited at the National Museum of Art in Sweden. But it's done using APL on a computer, and the printout given to the artist, who then made the piece of cloth with this pattern. Very modernistic. In Finland, Erkki Juvinen at IBM also became a big ambassador. I mean, it's interesting that IBM was this promoter and innovator back then, promoter of APL. But there was a guy at the Minister of Finance. They had a big data center, and that's Tauno Ylinen. He was on the board of the Finnish Computer Center, and under his leadership, APL was taught and used to service the governmental institutions in Finland. And again, it's very interesting. To this day, APL is used widely in the governmental institutions. Not so much in the industry anymore, but it seems to stay where it starts. So, I mean, that's a lesson. Go and plant seeds, and it'll stay there for a long time. We are into long-term software. So maybe a little bit slower start in Finland, but they actually did become the Nordic country with the most widespread use of APL. And here's a bunch of guys. You see them traveling to, I think it was the Washington conference, that one. It's Timo Laurma and Arthur and Erkki Juvinen, and right at the end, that's Tauno Ylinen. And there he is again. So, what about Norway? Nothing. Despite Iverson descending from Norwegians. But I think other things happened in Norway. They had these guys inventing Simula, and I think the whole IT crowd there was quite occupied with that. IPSA did have a small office in Norway, but they did service mostly the big multinationals that had their headquarters in the United States or otherwhere. So, how was APL used at that time? Lots of banks and insurance companies invested in computers to run their production. And APL was a natural choice. I mean, you have to remember, there weren't really any software back then. You had to pretty much do everything yourself. Companies who did not have data management, you could say, as their key production thing, used the time-sharing services to do their data gathering and manipulation. Public administration was a big user. They had their data centers where all the municipalities or all the governmental institutions got together and created service centers. An interesting thing was ATP. It's a countrywide system where every employee in Denmark has to have a little piece of pension paid to an account for them personally by their employer. So they, back in the early 70s, had the task of getting several million people on record with little payments every month or week, because some people had weekly pays back then. So what did they do? They built a database using assembler, and then they used APL for everything else: analysis, reporting, investment strategies, etc. Interesting times. IBM was a natural first mover with time-sharing services, but there's a bunch of people from the original APL implementation team that decided they want to go private with or separate with companies to do time sharing. And two of those were Scientific Time Sharing Company in the United States and IPSA Associates in Canada. And the dates here are, I mean, obviously IPSA predates APL, but they were servicing the Air Force industry. But somebody got Ian Sharp interested in APL. And so these two companies shared a big data center where IPSA sold time sharing in Canada and Scientific Time Sharing Corporation in America, in fierce competition, but still with the same data center. And even after they went separate ways and made each their data center, when their customer base grew, they still had hot backovers with each other. So this spirit of cooperation existed from the very beginning. So for a long time, Sharp APL and APL Plus was the same system. In addition to the time sharing service, IPSA developed this worldwide packet switch asynchronous network that allowed them to connect their big corporate clients with their daughter companies all over the world. That was actually a demand for companies like Xerox and who was the other big one? The camera country. Doesn't matter. So with that network, there was 666 box that was originally written when they were together, and which were really optimized at IPSA. So imagine back in the late 70s and early 80s, we had an email system working with APL that's pretty much like the internet today. The email system is very close to what you have on the internet, except you could, as Bob said the other day, withdraw a message. When you made a fool of yourself, you could withdraw the message and you would get a list of the people who had already read it. So you could write a little apologetic message to these few. So, no software. Packages were only started to come out in, IBM started in '73. So companies had to develop all their own software. Databases, counting systems, even had word processors in APL. And IBM developed something called APE, or we called it APE. It was Application Programming Environment, that helped. It was like a framework for doing screen pictures, screen forms, and tools to get at the different kinds of file systems. At IPSA, they developed template applications. MAPRA was a very early implementation of a relational database. COT had just published some years before that. So this was really, but it was a command-driven one. It was later replaced by Viewpoint, which is actually to this day the best, most user-friendly relational database front-end I've ever seen. Magic was a tool set for analyzing time series, and Magic Store is simply a huge multidimensional cube, and the framework just cut it up in little pieces so that it could fit into our 60K workspaces. Or they are 80K, and we had max 60K of data at a time, something like that. And STSC had Emma. I just added this because Roy has been talking about it a lot. So then we get to the 80s. A lot happened. There was a lot of smaller machines because the you know, the banks and insurance company had these mainframes, but production companies did not need mainframes, or they couldn't afford it. It didn't make sense for them. So there was a whole bunch of machines that were mid-frames, they were called back then, sort of data general decks, univacs, or no, what are they called? Yeah, smaller machines like that, with APL implementations, all of them. Yeah, the prime one, of course. And IBM, seeing that trend, introduced the 4300 series. It's a very cheap and reliable machine that IPSA or Sharp APL ran extremely well on that one. All sorts of anecdotes of 4300s that after 20 years it was decided it wasn't needed anymore, and they wheeled it out and wheeled it back in the next day because it turned out the corporation's annual fiscal accounts were made on that. So it was actually valuable information. And that's also the time where companies like IPSA started to make their APL available as an in-house system. So if you had a mainframe, you could get APL on it and run your company's business on it. There's quite a few companies did that, like for instance Nordic, the big pharmaceutical in Denmark, ran pretty much everything apart from their production control systems on APL. The PCs started when I was on that course in '83. They showed us a draggable IBM computer. It weighed more than 20 kilos, but the auditors was very infatuated with it and loved it with APL. The APL Plus PC was released, a major step for all the people who sort of got sidetracked in the mainframe environment. They could now start doing their stuff on PCs. And we started to see shrinkware products and relational database systems. And Dyalog Systems launched Dyalog APL for Unix. So, where was APL used? Banking and insurance, where it's always been. Public administration, big production companies, multinationals. Postibanki has an application that was downsized, I think in '96, that's still used to this day, doing analysis on company accounts, sort of evaluating companies for one of the biggest newspapers in Finland. So the 90s, right, turn of the tide. It's a dark decade. We got Windows 3.1, lovely, lovely. And together with the internet that started to really gain speed then, it made personal computing very approachable. We started to get word processors. WordPerfect had been something that a pro could use. That was it was very powerful, but it had some odd key sequences that you had to know. But by God, when a woman knew that, she could get some typing done very quickly. But then we had Word for Windows. Just a little anecdote. The big Nordic, they used WordPerfect. So they had quite a few people, secretaries and other administrative staff, trained in WordPerfect. IBM, they were following IBM quite closely. So they had obviously strategically decided they would go to OS/2 and not Windows. At the same time, there was this decentralization trend in business. So instead of having a huge corporate centralized budgeting, they had a departmental budgeting. introduced. So what happened was that after 1 year, Nordic had 200 OS2 users, all in the IT department, and more than 1,000 Windows licenses. So obviously people started using Word for Windows, and it took 3 years before the board made the decision that they could go to Word for Windows instead of WordPerfect, because the training required to do WordPerfect was really a big cost. And they thought that they would obviously have to retrain all these people to Word for Windows, but it was so intuitive that people just used it. They didn't need any training. So as that became clear, that process just went on. Right, accounting systems, email, spreadsheets, spreadsheets. That took away a big part of the APL market, because every installation had a spreadsheet written by some APLer, so people could take the data from the repositories and produce reports, compare data, make their own calculated columns. IBM Support for APL faltered. IBM had this idea back in the 90s that they would have one programming language that would cover all their platforms. Even the AS400, which was pretty much a digitized relational database that didn't have floating point arithmetic. IPSA got bought by Reuters and sort of disappeared from the APL market because Reuters really liked the time series databases that IPSA had gathered over time, but they did not understand this software business. So they bought the whole thing and spat out again the software business, amongst this the Copenhagen office, which at what time we created Inside Systems. But lots of systems were downsized because the PCs were now powerful enough to run a lot of the systems that had been running on the mainframes. Others were rewritten in other things or attempted replaced with a customizable framework system. The users very often didn't like it, but strategic decisions in business does not often take users into account. But the APL consultancies that had had a huge business in the 70s and 80s obviously also saw the writing on the wall and started to do custom software, develop software that could be sold more than once. And a lot of them had a big experience with what was expected out there and could turn that into software. And this is when SimCorp started to turn from a consultancy to a big software vendor that they are today. At Inside Systems we did the SQ APL that I think spread to most APL systems. At least we sold it to all the important vendors except IBM, who did their own version. Now, one thing being an APL user in the 70s and 90s, because you, as Roy put it, you didn't have to think about the machines, you didn't have to understand them, you didn't have to be sure you had a backup. It was all done for you. All you had to do was sign on to the system and start solving problems. With the PCs and the downsizing, all the users were now, well, if you got a personal computer, you had personal problems, because you had to take care of the backups and understand how the networks worked. And the other thing you had to do was, with a very poor set of tools, you had to create a user interface in the Windows environment, and that was not an easy thing. Dyalog had a really good set of tools. These decisions, little decisions you can say, actually decides whether you're gonna take the market or not. One thing that was very important for Dyalog was the OS2 thing. IBM was really pushing OS2 to the whole market. And it had a Windows box, and Dyalog could run in the Windows box. But because of the choices that STSC had made, they could not. So that made the market for Dyalog in Europe. That's how Dyalog won the European market. They could tick a box. Nobody ever did that, because it would have slowed down the whole thing immensely. But it ticked the box. And that's, you have to be aware of tick boxes. So in the noughties, very often we are accused as APLers as being very religious about APL. But what are they? They have ideas about what is kosher or not. Right. Corporate infrastructure safely in the hands of the professionals. Data under lock in the data jailhouse. Data modeling, all that. And you had to make an order quite early on if you wanted a specific report on the data. Or you could use spreadsheets, and lots of people did. So instead of using APL, they used spreadsheet and built huge conglomerates of spreadsheets that did the corporate annual reporting and stuff. And when the guy who did it left, nobody had a clue how to do that report the next time. So software development turned into a branch of engineering, but it started to dawn upon people that that model doesn't really work. There was this famous standards report where they looked at big projects, software projects, both in the public and the private sector. And it turns out that only about 30% of IT projects succeed, means it finished on time with the required functionality and within budget. 25% fail completely, never flies, never gets on, never get used by anybody. And about half of them, 45%, are challenged, meaning they are delayed, their requirements are cut, or they are vastly more expensive than planned. And there's been quite a few studies done on that, and one of the two top reasons for project failures quoted is lack of user involvement. So APL was still used, but not in the IT departments, not in the engineering way. But there's still financial analysis that has to be done, even if the rules has changed yesterday or this new instrument is available. There's budgeting, trying to model what the company is going to look next year. Asset management, risk analysis, business intelligence, big data analysis. Well, that's a new buzzword, but we were still doing it back in the noughties. And then there's a whole new area, bioinformatics, that starts to grow because large databases of clinical data, for instance, becomes available. No tools available for researchers to explore that data. The genome is mapped. Really a whole new research area where oodles of combination needs to be explored to check out what's really happening here. So APL is a tool of thought. It's mathematical, array-oriented. The development environment gives you an easy access to the environment. It's easy to integrate things with APL, if it's the right APL, of course. Because the APL vendors, our main task is not to invent the language. It has been invented. It's math. It doesn't change that quickly. We add things when they're necessary, But the key task is to make sure that APL as a technology is available in the right context, so that you can use it as a glue, so you can get at all the external things. And that's the Sisyphus job, because once you finally got Windows under control, now you want to do cloud. Okay, so we start all over again. But we do it happily when we see your faces when you actually get something to work. It's a reward in itself. Most important additions, the generalized arrays, I agree, it's probably the most. I think that came along because of the relational data model. The databases started to become a commercial product, and IBM had nothing that could take the tuples from DB2 and do stuff with it, so they just changed APL, and that was the easy way. In '95 we got control structures, and that spread to pretty much all the APL implementations. So that naked branch thing, it was cute. And you could just jump to 6 different places depending on what the outcome was. But everybody else read if then else better than naked branches. So it looks more, it's another tick box. And it's quite useful. It actually does make your code more readable. The defense start in '96. Has turned out to become quite important now that functional programming are the thing to do for parallelization. The defense are really important. And then futures and isolate. I don't know if they belong there, but I suspect they do. And in 10 years' time, we can reevaluate this. So current APL, modern dynamic multi-paradigm programming language with a focus on arrays. Thanks to Unicode, we don't have a problem with APL symbols anymore. Modern APL is a tool of thought for talking to a computer, speaking to a computer, or speaking to another human being. And most useful, the fact that the main expertise of the user is important. And with APL, you don't only put the domain expert next to the development. The domain expert is actually the developer. And then they probably need some assistance from some software engineers to get the whole thing to spin. But solving the problem is the task of the user. I'll just go very quickly past these because you know all these systems, you tried it. Because I want to show you this. This is from last year, realization from Gartner Group. They talk about Bimodal IT. And I think this is a very important development because it's like we have been, as APL users, squeezed a little bit about the struggle to get the corporate IT infrastructure in place so that all the data are handled and all the backups are done and all the security is in place. And sometimes we've been a little bit of a spanner in that. But now they talk about the mode 1 is getting all that infrastructure in place. And that's a different thing than creating the business logic, the stuff you need to expand your business, to change a whole area of business. And you need the agility and the non-linear development to do that. And think in this mode 2, APL has a very important role to play. I don't know if Gartner Group knows that, but I shall try and get them to understand it. The standards report data I was talking about was analyzed by a guy some years ago, and he sort of sorted the failed, succeeded, and challenged project by size of project. And there turns out to be a very strong correlation between the size of the project and the risk of success. If your project is less than $0.75 million worth, you have more than 50% chance of a success. If your project is bigger than $10 million, you have 0 chance of success. They are all either failed or challenged. So, just in summary, APL teams are small, even for complex projects. They very seldom get over the 0.75 million. Agile programming has been practiced by APLers since the early 70s. I mean, we could claim to have invented it. Not only have we had the users closely involved, we have been implementing our own solutions, and I'm sure we'll continue to do that for the next 50 years, given the right tools. And APL projects don't fail. Right, no questions. I think I've expired.
Okay, thank you very much, Gitte.